Look up at the night sky. Appen. Now imagine this. Space isn't black. There is no darkness between the stars, no deep void, no comforting shadows. Instead, the sky above you is bright, a glowing, endless ocean of light stretching in every direction. The stars are still there, but they're drowning in a luminous fog, as if the universe itself forgot how to turn the lights off. At first, it's beautiful. Cities no longer need streetlights. The Milky Way isn't a faint smear, it's a blazing river across the sky, visible even at noon. Astronauts don't float in darkness anymore, they drift through a radiant cosmic glow that never fades. But then, things start to feel wrong. Astronomers panic as telescopes fail to see deep space. Satellites overheat as constant radiation pours in from all directions. Night disappears, not just from the sky, but from biology itself. Animals lose their sense of time. Human sleep cycles collapse. The universe, once a place of mystery, becomes an inescapable flood of light. Then the biggest question hits scientists like a shockwave. If space isn't black, where is all this light coming from? Because for space to glow, something terrifying must be happening at a cosmic scale. Light must be bouncing endlessly, trapped, unable to escape. That would mean the universe is no longer expanding the way we thought, or worse, it's collapsing, reflecting its own energy back onto itself like a hall of mirrors with no exit. In this glowing universe, darkness, the very thing that allowed stars, planets, and life to exist, may have been an illusion we were lucky to have. And if space suddenly stopped being black,
It wouldn't just change the night sky.
it could rewrite the laws of reality itself. Please like this video, subscribe to the channel, and comment your question below. To understand this impossible universe, we need to start with a simple question. Why is space black in the first place? It's not because there's nothing out there. Space is filled with stars, galaxies, radiation, and leftover light from the Big Bang, yet between those objects, darkness dominates. That's because light usually travels in straight lines, spreading out, weakening, and eventually missing our eyes. Most of it never reaches us. Now imagine a universe where that rule breaks. In this scenario, space itself is no longer transparent. Instead, it scatters or reflects light, like a cosmic fog or a mirror-filled void. Every photon emitted by a star doesn't just fly away into infinity. It bounces, it ricochets. It fills the gaps between galaxies, building up brightness over billions of years until the universe glows everywhere, all the time. Scientifically, this idea is fascinating because it attacks the foundations of physics and cosmology. It challenges how light behaves, how energy spreads, and even how space expands. Astronomers have a real concept called Olber's paradox, which asks, if the universe is full of stars, why isn't the night sky bright? The darkness of space is actually evidence that the universe has a finite age and is expanding. So in our hypothetical world, something has changed. Either space has gained properties like dust on an unimaginable scale, or the expansion of the universe has slowed, or reversed, trapping light inside it. Another possibility is even stranger. The universe has become optically thick, meaning light can no longer escape without colliding with something. In this video, we'll explore what that would mean step by step, how a glowing universe would affect vision, astronomy, planetary temperatures, life on Earth, and the ultimate fate of everything that exists. Because when space stops being dark, it stops being safe. The first and most immediate consequence of a non-black universe would be the death of deep space as we know it. In our real universe, darkness is a gift. It allows astronomers to look outward and see faint galaxies billions of light years away. Telescopes depend on contrast, the difference between bright objects and a dark background. But if space itself glows, that contrast vanishes. Imagine trying to spot a candle flame in a room where every wall, the air, and even the ceiling are glowing white. That's what astronomers would face. The cosmic background light would overwhelm every telescope, no matter how powerful. The James Webb Space Telescope, Hubble, and every future observatory would be blinded by the universe's own brightness. This isn't just a technological problem, it's a physical one. If light is scattered everywhere, it means photons are constantly colliding with particles, dust, or warp space itself. Each collision transfers energy. Over time, that energy builds up, slightly heating everything it touches. Intergalactic space, once near absolute zero, would begin to warm. Gas clouds that normally cool and collapse to form new stars would struggle to do so. Starbirth would slow, some regions might stop forming stars entirely. Ironically, a brighter universe could become a dimmer one over time as fewer new stars ignite to replace the old. Even worse, navigation across space would become dangerous. Spacecraft rely on dark backgrounds to track stars and measure position. In a glowing universe, orientation becomes unreliable. Cosmic landmarks blur together. Long distance space travel turns into flying through fog without headlights. On Earth, the effects would already be noticeable. The night sky would never be truly dark. Amateur astronomers lose the stars. Cultures that use constellations for navigation and storytelling would watch the sky's patterns dissolve into a uniform glow. Humanity wouldn't just lose the view of the universe, we would lose our window into the past, because looking deep into space is how we look back in time. And in a universe without darkness, the past becomes invisible. As the universe continues to glow, the consequences don't stay limited to astronomy. They begin to rewrite planetary environments, including Earth's. The constant background light adds energy everywhere. Not a blast of heat like sunlight, but a steady, inescapable drizzle of radiation coming from all directions. Planets are no longer cooling efficiently because cooling requires radiating heat into cold, dark space. But space is no longer cold. Earth starts to trap warmth. At first, the change is subtle. Nighttime temperatures stop dropping as much. Deserts remain warm after sunset. Polar regions lose their deep freeze. Then feedback loops kick in. Ice melts, lowering Earth's reflectivity. Oceans absorb more heat. Weather systems grow stronger and less predictable. Unlike sunlight, this energy can't be blocked by clouds or shade. It arrives from above, below, and even through the ground after being absorbed and re emitted by the planet. Darkness, the natural reset button for climate, no longer exists. Biology feels the impact next. Most life on Earth evolved around a light dark cycle. Plants rely on night to rest their photosynthetic systems. Animals use darkness to regulate hormones like melatonin. In a glowing universe, circadian rhythms collapse. Migratory patterns break. Nocturnal species lose their ecological advantage and begin to vanish. The oceans suffer too. Many marine organisms depend on darkness at depth. With constant background light penetrating deeper waters, ecosystems destabilize. Coral bleaching accelerates. Food chains fracture from the bottom up. Step by step, the chain reaction grows.
Space glows.
Climate destabilizes. Biological clocks shatter.
Ecosystems collapse.
And this is happening without a single star getting brighter. The universe hasn't exploded. It hasn't burned. It has simply refused to go dark, and that may be even more dangerous. Over long cosmic timescales, a universe that cannot become dark begins to face a far more serious problem. It cannot get rid of energy.
Physics, survival depends on balance. Stars shine because energy can escape. Planets stay stable because excess heat radiates away into cold space. But in a glowing universe, that escape route is blocked. Energy piles up.
Galaxies slowly heat from the inside out. Stars burn faster than they should, not because they are producing more energy, but because their surroundings are warmer. The pressure balance inside stars changes. Some swell into red giants earlier than expected, others collapse violently, triggering more frequent supernovae. But those explosions don't solve the problem. The energy from supernovae has nowhere to go. It scatters, reflects, and returns. Over billions of years, interstellar space approaches a thermal equilibrium and nearly uniform temperature everywhere. The universe starts to resemble a giant oven set to low, but permanently on. This creates a horrifying paradox. Life requires energy differences, hot and cold, light and dark, high and low entropy zones. In a universe filled with uniform glow, those differences disappear. Chemical reactions slow, complex molecules become harder to maintain. Evolution stalls. Eventually, even black holes are affected. Normally, they sit in near zero temperature space, slowly evaporating through Hawking radiation. In this glowing universe, the background radiation is warmer than the black holes themselves. Instead of losing mass, they begin absorbing energy. Over unimaginable timescales, matter, radiation, and even light drift inward. The universe doesn't end in a fiery explosion or a cold freeze, but in a slow, luminous suffocation. A fate stranger than heat death. A universe that is bright, but dead. Because darkness wasn't emptiness. It was the universe's way of breathing. Let's step back and look at what this glowing universe has taught us. Space isn't black by accident. Darkness is not a flaw in the cosmos, it's a feature. It allows energy to escape, temperatures to stabilize, and life to find rhythm. When space turns bright, the universe begins to choke on its own light. In our scenario, the first casualty was knowledge. Astronomy collapsed as telescopes lost contrast. The universe's history faded behind a wall of glow. Then came environmental chaos. Planets stopped cooling, climates spiraled. Ecosystems built on the simple cycle of day and night fell apart. On longer timescales, the damage became irreversible. Energy trapped itself. Stars burned out of balance. Chemical complexity declined. Even black holes, once the universe's ultimate sinks, began to grow uncontrollably. The cosmos drifted toward a uniform, glowing equilibrium, bright, warm, and lifeless. What makes this scenario truly unsettling is how quiet it is. No explosions, no sudden destruction, just the slow loss of contrast. The difference between light and dark, order and chaos, life and entropy. So the next time you look up at a black night sky, remember this. That darkness is the reason stars can shine. It's the reason planets can cool. It's the reason life can exist at all. A universe without darkness isn't enlightened. Well, it's suffocating.